hit up section 2.2. Section 2.2 is pretty short. It's only about one idea, and that's called subsets. Okay? Subsets are, think about it like this. Say I have a bag of M&Ms, and I come around to you, and I let you select 5 M&Ms out of it. Okay? But you are really picky about your M&Ms, and you are kind of bougie that way, and you only like the red M&Ms. Red M&Ms are the ones that taste the best to you. And so you only eat red M&Ms. So you take 5 red M&Ms from my bag. What you have done is you have grabbed a subset, okay? Because you only eat red M&Ms, that's like a subset. That is part of the original bag. Because the original bag of M&Ms, if I remember right, what we got? Red, we've got blue, we've got brown, yellow, and green. Okay? Because there are 5 colors total, but you're only eating one of them, the reds, that's a subset. Because you are taking a piece of the entire set. Think of subsets kind of like pieces of the set. All right. Sometimes you can take the whole set. Sometimes you don't have to take anything from the set. Those are also considered subsets as well, too. We'll talk more about that in a section. But to kind of give you an idea of what subsets are like, kind of like a more tangible one, it's like you have a bag of M&Ms and you only eat the reds. Okay? You're eating a subset of the bag. You're eating one of the colors out of the 5 out of the bag. Okay? You couldn't, if I came around to the bag of it with a bag of M&Ms and said I only eat the purple ones, that's not a subset of the bag. There are no purple M&Ms in the original M&M packaging. Okay, the only colors you get with the original M&Ms are brown, red, yellow, blue, green. Okay, there is no purple, so purple is not a subset of the original bag of M&Ms. Okay. So, kind of clarifying that just for you. So, subsets says that every element in set A is an element in set B. That means whatever you're grabbing for your set, they are parts of the original set. Okay? They are parts of the original set. Notation looks like this. A is a subset of B. So subset is like a C, a weird elongated C, with a line under it, kind of like half of an equal sign. Okay? This means that these parts in A are all in B. I'm eating my red M&Ms out of a bag of M&Ms. That's a subset. Okay? This first set are pieces of the second set. So anybody that you put in the first set has to appear in the original. Okay? So, for instance, let's write out all the subsets of A, which are the numbers 1, 2, and 3. So, thinking back to like my bag of M&Ms, I could have the subset 1, because maybe I only like to pull out the number 1. Well, that means you could also have a subset of 2 and a subset of 3. Those are all subsets of the original because the number 1 is in set A. The number 2 is in set A. The number 3 is in set A. These are all pieces of the original set. But let's say that we're greedy. Maybe I like the number 1 and the number 2. So I'm going to pull that out. This is also a subset of that because both 1 and 2 are in the original set. Or maybe you like the set 2 and 3. Maybe you only wanted to use the numbers 2 and 3. So that's a subset. And then there's a third one, the set of 1 and 3. So again, These are all subsets because 1 and 2 are in the original. 2 and 3 are in the original. 1 and 3 are in the original. These are all pieces of the original. Okay? And then, as I said a moment ago, the entire subset is a subset of itself. Oops, not making the squiggles yet. So the set 1, 2, 3 is a subset of itself, 1, 2, 3, because 1, 2, 3 are all elements in 1, 2, and 3. And then also, the empty set is a subset of itself because I don't have to grab anything from the set. You know, I could come around and say, do you want any M&Ms? And you'd be like, no, man, I'm good. That's a subset. Not having anything is a subset of this guy. Okay? The empty set is always a subset of a set. Okay? No matter what the set is, the empty set is always going to be there. And no matter what the set is, the entire set is a subset of itself. So right here, what I'm classifying as B, if I put my little braces around it, what we have just did then is the set B is the set of all the subsets. So right here, this is what a set B could look like, which is the set of all the subsets of A. These are all the subsets of A. So as I was saying in the previous section, 2.1, you can have sets that have sets in them, okay? Because I have a total of 1, 2, 3, 4, 5, 6, 7, 8 sets here. So now you know the cardinal number of B. Oops, not an M, silly me. So the cardinal number of B equals 8, because there are 8 subsets in there, okay? Sorry, 8? Yeah, 8. So again, all that I'm saying here is that subsets are pieces of the original. It can be the entire set, that's A-okay. It could also be nothing as well. All right? Now, let's take a look at this and let's talk about whether these things are subsets or not. Okay? So, and I totally messed up on this piece right here, so let me do some fixing real quick. Add symbols up here. Oops. Oh. Symbol should be the subset symbol, which looks like that guy. And then I should have another one over here. Silly Mr. Armstrong. Fixing that. There we go. I'll fix my little line right there. There we are. All right. Group. And that back together. There we go. Now we're all good. So the question is this a subset of this one? Okay, so if we look at 1, so we've got the numbers 1, 2, and 5. Are 1, 2, and 5 pieces of this original? 1, 2, 5? Yep. So it is a subset. Simple enough. So in your assignment, generally what it will be is like a multiple choice. You either choose this symbol or you choose that one, or it's a drop-down menu and you'll select the symbol that you want. This one right here, again, it has the line through it, just like when we had the not an element of. This means not a subset. Okay. So 2, 3, and 7, is that a subset of 1, 2, 3, 4, 5, 6, 7? Absolutely, because 2, 3, and 7 are all in this set, so it is a subset. What about -3, 0, and 3? Is that a subset? Nope. It has the -3 and the 3, but this guy has a 0. Do you see a 0 over here? No. So that is definitely not a subset. Okay. All right. So let's take a look at some other questions that I have down here because I have quite a few. You kind of got an idea of what's going on. Take a look at number 5. Think about that one. Take a look at number 9. And take a look at number 13. Try those real quick. Pause the video. Question is, are they subsets or not? Go. All right, hopefully for number 5, you said that this is not a subset because this guy has Friday and there's no Friday down here. Okay? If you look at this, all you had to do is just see if all the letters in conversation are down here in voices ranton or voice ranton, whatever. So we definitely got a C, we got a C, we got a go, we got an O, we got an N with an N, a V with a V, an E, E, R, R, S, S, A, T, T, I, O, O, N, N. So definitely all the letters that are in the first set are in the second set, and there's no more or less. So these are definitely, hopefully you said subset. And then last but not least, number 13, this is the empty set symbol. So is the empty set a subset of this one? Always. The empty set is always a subset of this guy. Look at number 15, though. Let me reverse this on you. Is the set 2, 4, 6 a subset of the empty set? And the answer to that one is no. This is not a subset because 2, 4, and 6 are not in here. Remember, whatever's in the first set has to be in the second one. And since this set has nothing, that's impossible to happen. Okay? And go ahead, let's think about this last part. Is the empty set a subset of the empty set? Absolutely. Empty set is always a subset of the empty set. Okay? Because it's just the empty set and the empty set. They're both the same. Cool, cool. Yeah, that's what a subset is. Okay? It's just about pieces. Are the pieces of the first set in pieces of the second? Okay? Now, there is something called a proper subset. Proper subsets are easy to distinguish. Here's what makes a proper subset. First off, the two sets have to be a subset. Okay? If the two sets are not a subset, you can't have a proper. It doesn't work like that. All right? So you have to be a subset to begin with. And then, what's the difference between a proper subset and a subset is that propers are not equal. Okay? Propers cannot be equal. All right? So basically what that means is all subsets are proper except for the two sets that are equal. Okay? So in other words, the set that represents the set, so like for instance, right here, conversation and voices ranting, these are just a subset because they are equal. These are not proper because, again, they're equal. You are only proper if you are not equal. So any set that is the actual set, so the first set is the same as the second set, equal, in other words, you are not proper and you will never, ever be proper. So, for instance, all of these are proper subsets because they are not equal to the original. The only one that is not the proper is the one that represents the same set, the one that is equal. Okay? So whenever you're thinking about subsets, everybody's proper except the one that is the original set. You throw it out. Okay? So proper subsets means that you are a subset, but you are not equal. Notation for it, you drop the equal part under it. Okay? So that line right there does represent part of an equal. All right? Okay. So let's talk about some things that you're going to see here now. So they love these questions. Okay, they want to know, is it a proper subset, a subset, both, or neither? Now let me tell you about this real quick. One of these answers, there are 4 up here. One of these answers will never ever happen, and that is this guy. You cannot be just proper. That doesn't make any sense, because the first thing to be proper is you have to be a subset. Okay? So if you're going to say it is a proper subset, then that means it was a subset to begin with. So that answer of just proper subset will never ever happen. You can throw this guy out. So now you have a 1 in 3 shot. You're either a subset or both or neither. Okay? You're either a subset, both, or neither. So if we look at this guy, first off, is 1, 2, 3 a subset of this? Absolutely, because the numbers 1, 2, and 3 appear in the second one, 1, 2, and 3. So we know it's a subset. So we're between these two answers. The question is it proper? Well, does this set equal that set? No, because this one only has the numbers 1, 2, 3. In order to be equal to this one, it would have had to been 1, 2, 3, 4. So since they are not equal, that means this will be both. This is proper because they are not equal. Okay? So the first thing you're going to do is decide if it's a subset. And then after that, you got to decide if it's proper. If it is proper, select both. If it is not proper, select just subset. If it's not a subset to begin with, then you select neither. Okay? So I got just a couple examples here left. I think that's it. Nope. Got one more pieces that just a couple more pieces right after that. So let's take a look. So again, up here, one of these answers doesn't make any sense. It's this guy. So it gets thrown out. Okay? So go ahead and take a look at look at 19. Look at 20. And look at 25. And go. Okay. So VCR. Well, VCR are definitely in VCRS. Okay, so we know it's a subset. Is it proper? And yes, it is proper because this set is not equal to that set. So we know that this is going to be a both answer. Okay, down here we got 0, 2, 4, 6, 8. Are all these numbers in the second set? Absolutely. There's a 0, there's a 2, 4, 6, and 8. So it's definitely a subset. Is it proper? And the answer is it is not proper because these two sets are equal. All of these numbers are right here in the second set. So that just means this is just a subset because it is not proper because they are equal. You cannot be a proper subset if you are equal. Down here, number 25, see if you thought about this. It says a man, so any man, is it a subset of a person? Absolutely, because a person is one or the other. Okay? Or maybe both, but it still counts. Okay? So being a man is definitely a subset of a person. Now the question is it proper? Does this set of being a man equal the set of being a person? And no, it doesn't equal it because being a person, you can be female. Maybe you come with both gender stereotypes. Okay, knowing nowadays things, the possibilities are limitless. So this is actually a both. Because again, being a man is definitely a subset of a person, and being a man is definitely not equal to being a person because there are lots of different types of people out there. Okay, so it's definitely both. Let's scroll down. Let's look at a couple more. Give you some shots here. Let's go ahead, look at number 29. Give that one a shot. All right, so on this one, you definitely want to look at the roster. for both of these. So up here, it says we are natural and we are between 5 and 12. And we do not like 5, we do not like 12. So that means we're up at 6, 7, 8, 9, 10. Oops, and 11. Looking at this one, again, it says naturals, and we're between 5 and 12. So again, that's 6, 7, 8, 9, 10, 11, 12. So, oh, sorry, no 12. We're between those numbers. So if we look at this, are all the elements in A and elements of B? Absolutely. So it's a subset. Are they equal? And yes, they are. So since they're equal, you cannot be proper. So this one just has the symbol subset. Okay? Go ahead and look at number 31. Give that one a shot. Go. Okay. So again, this is the same roster that we had up above. 6, 7, 8, 9, 10, 11. Okay, down here, set of natural numbers is between 3 and 17. 4, 5, 6, 7, 8, 9, 10, 11, 12. This is a bad habit. Do not do this. Normally, when you are writing sets, you want to have them all in one line. 13, 14, 15, 16. So there's the set. So are all the elements of A and elements of B? Absolutely. Are they equal to each other? No, they're not. So that means this is both. Okay. Scrolling down a little bit more. Go ahead and give number 35 a shot, and 38 and 40. Okay. So, looking at this one, is the empty set a subset of this? Absolutely. The empty set is always a subset. Question is, are they equal? Well, no, they're not. This one has nothing, and this one has lots of numbers, 7 to 100. So again, this answer is going to be a both, because it is a subset, and they are not equal. So that means it's proper. Down here, hopefully you said on this one that this is neither, because none of these elements are in the empty set. So this is definitely not a subset of the empty set, because this one has elements, this one doesn't. And then down here at the bottom, hopefully you just said that this was a subset, because the empty set is definitely a subset of the empty set. We've already talked about that. But they are also equal. This has nothing, this has nothing. So that's why it's not proper, it's just equal. Okay, because they are the same set. All right. So again, that's what some of your homework looks like. Again, you'll have, multiple choice options of one to select, or sometimes it's a drop-down menu on these kind of questions. All right, so on this one, I made up some sets and I asked some questions. I'm actually, I decided I'm going to throw this page out. We don't need that page. Okay. So now, one last thing I want to talk about is kind of something that, and then we'll do some true and false, and then we'll be done. So I want to talk about the number of subsets. So let me give you some information. I want to see if you can catch on to what's going on. So if I have a set of one element, okay, that means there are two subsets. Give you an example of here. So let's just say I have a set of the number 5. So the subsets of this guy are 5 and the empty set. See, just two sets. 1, 2. So that means there were two subsets. If I had two elements, that means they have four subsets. So again, I'll show you an example. 5, 6. So that's my set. So I have the set 5. I have the subset 6. I have the original set 5, 6. And we also have the empty set. Okay, so there's 1, 2, 3, 4 subsets. 3, you already saw that earlier. We did that with 1, 2, 3. So there are 8 subsets. How many subsets are there going to be with 4? Again, you don't have to write these all out. Hopefully you're starting to see a pattern. Okay, so hopefully by looking at this, you say that there are going to be 16 subsets, Mr. Armstrong. And I would absolutely agree with you. There are 16 subsets. How many are there going to be with 5? Well, with 5, there are going to be 32. Because hopefully you're noticing that all we're doing is taking the number that we had and we're multiplying it by 2. That's how we're jumping from one number to the next. Well, what if we had n subsets? Or sorry, n elements. How many subsets are there going to be? Okay, so if I had n elements, what is n? I don't know. Could be anything. All right. So n, if you haven't kind of thought about this before, this pattern of multiplying by 2 every time, that's exponential. That's an exponential pattern. Hopefully you kind of remember that from Algebra 1, Algebra 2, maybe if you've taken college algebra, because we talked about this a little bit. But this is exponential. And if you have n elements, if you want to know how many subsets it's going to have, you're going to take 2 to the n. Okay? Because if you go back and look at this, well, there was one element here. So 2 to the first power is just 2. There were 2 elements here. So 2 to the second power is just 4. There were 3 elements here. 2 to the third power is just 8. And so on and so forth. So if you have n elements, there are 2 to the n number of subsets. Kind of food for thought. Kind of interesting. Nice little number pattern. I do want to ask you this real quick question. How many proper subsets are there? Well, remember, all we do is we take off the original set. So right here, here's the original set. So if I take that off, there was one proper subset for one element. And it's the empty set. Okay? If we have 2 elements, we take off the 5 and the 6 one. So that means that there were 3 proper subsets. Down here, we've already did the 3, and I've shown you that if we take off the original, there were 7 proper subsets. What do you think is going to happen with this 16 here, number of subsets? Hopefully you said it becomes 15. And then down here at the 5, hopefully you tell me that this becomes 31. So if I want to know the number of proper subsets, hopefully you caught on to the pattern. All you do is take 2 to the n minus 1. Because all you're doing is subtracting off the original subset. That makes it equal. And that tells you the number of proper subsets. Kind of cool. Neat little math trick. All right. And so last but not least, in here, it kind of takes everything that we've learned and kind of puts it all into one little question right here. Again, they're just going to ask you some true or false. Okay. They want to know true or false. Is what's going on what going on? Okay. So let me give you some problems. Go ahead. Try 41. Try 44. Let's do 46, 48. Give that one a shot. Number 50, number 52. Yeah, try those. And go. True or false? Okay, so remember this little symbol right there means element of. So is Ralph inside this set? Absolutely, there's Ralph. So this is true. Okay, right here, again, remember what the symbol means? That means subset. So is Canada a subset of this? And no, it is not. Okay, because this is an element. Okay, this means subset. Okay, this is not a set. This is an element. So this is actually false. Even though, yes, you see Canada, Canada. What this symbol should have been is element of. Okay, because this right here is an element, not a set. And this symbol is all about subsets. Okay, so 46 is why I gave you this question to follow up with that. This is the true statement because the set Canada is definitely a subset of the set of Mexico, United States, and Canada. See, there's set notation there. Okay? Some of these names tell you exactly what you should be looking at. Elements should be about elements, no sets. Okay? Subsets should be about sets. Okay? And this is definitely about a set. All right, down here, is the empty set a subset of this? Absolutely. We talked about that. Kind of a nice little recap there. That is always true. The empty set is always a subset of any set. Number 51, is the set 1 an element of this set? Absolutely. This is true. Going back to what we talked about in that section 2.1. Okay. This element right there is that element right there. See, it matches 100%. So it's definitely true. And last but not least, is the set 1, 4 not a proper subset of 4, 1? And that is true. It is not proper. Okay, it is a subset, yes, but it's not a proper subset. Okay, and that right there wraps up 2.2. Hope you enjoyed it. I hope you got some information. If you need anything, just text me, call me, email me, let me know.